This video is brought to you by mywayteaching.com.
Next is valence bond theory. Valence bond theory was introduced by Hitler and London and developed to further by Pauling and others. Based on the knowledge of atomic orbitals, electronic configurations of elements, and the overlap criteria of atomic orbitals, the hybridization of atomic orbitals, and the principle of variation and superposition, valence bond theory was introduced. Okay, so here, before going to that, uh, it is some consider the one example, that is forces of attraction and repulsion during the formation of H2 molecule. Okay, here consider the two hydrogen atoms A and B. Consider two hydrogen atoms A and B, and approaching there having the nuclei Na and Nb. Okay, and the electrons in them A and Eb. When the two atoms are at the larger distance from each other, there is no interaction between them. As these two atoms approach each other, new attractive and repulsive forces begin to operate. They are, when this is A and this is B, they are approached towards each other like this. There is a attractive, new attractive and new repulsive force begin to operate. Attractive forces arises between, see here, as shown in this figure, there is attractive forces arises arises between nucleus of one atom and its own electron, that is NaE and Na. First one is NaEb. Here nucleus of one atom and it's with its own electron. Okay, and next is forces of attraction, it arises in between. And the second one is nucleus of one atom and the electron of other atom. Nucleus of one atom A and the other atom electron is Eb. Nucleus of one atom and the electrons of another atom. So similarly, repulsive forces, this is the attractive forces. Okay, and like repulsive forces, this is as shown in this figure, this is the attractive forces. Repulsive forces arises in between them, like so electrons of two atoms like EAEB and the nuclei of two atoms Na and Nb. This is the repulsive forces arises between, this is the attractive forces arises in between. Okay, so this is the attractive forces, this is the repulsive forces. Next, this is the figure, the potential energy curve for there is an energy curve for the formation of H2 molecule as a function of internuclear distance of the hydrogen atoms. The minimum in the curve corresponds to the most stable state of H2. Minimum in the curve represents the most stable of H2, state of H2. Next, orbital overlap concept. Okay, what do you mean by orbital overlap concept? In the formation of hydrogen molecule, there is a minimum energy state when two hydrogen atoms are so near that their atomic orbitals undergo partial interpenetration. Okay, this is a partial merging, this is like merging. Okay, partial merging of the atomic orbitals is called overlapping of atomic orbitals, which results in pairing of the electrons. So this is the merging of the orbitals, that is called overlapping concept. And next, directional properties of the bonds. The covalent bond is formed by overlapping of atomic orbitals. The molecule of hydrogen is formed due to the overlap of oneness of two hydrogen atoms. The covalent bond is formed by overlapping of atomic orbitals. Okay, the molecule of hydrogen is formed due to the overlap of oneness and of two hydrogen atoms. In case of polyatomic like CH4, NH3 and H2O, the geometry of the molecule is also important in addition to the bond formation. Okay, next, the valence bond theory explains the shape, the formation and directional properties of bonds in polyatomic molecules like CH4, NH3 and H2O, etc. In terms of overlap, the hybridization of atomic orbitals. In terms of overlap and the hybridization of atomic orbital, it will explain. And the next thing is, this is overlapping of the atomic orbitals. When orbitals of the two atoms come close to form bond, okay, come close to form bond, their overlap may be positive, negative or zero. The overlap may be positive or negative or zero when they are close to each other, depending upon the sign and direction of orientation of amplitude of the orbital wave function. Okay, positive negative sign on boundary surface diagrams. So this is the figure, positive, negative and zero overlaps of S and P atomic orbitals. So here in this side it is showing positive overlap. Only positive signs are overlapping. This is the positive and negative like this. Okay. Where in the zero overlapping, this is the zero overlap. Okay. So this is the overlapping of atomic orbitals, positive, negative and zero. And the next is types of overlapping. In that, there is a sigma bond. This type of covalent bond is formed by the end to end overlap of bonding orbitals along the internuclear axis. There are the two types of bonding, sigma bond and pi bond. In that, there is a sigma bond, SS overlapping. In the SS overlapping, this is the S orbital, this is also S orbital, this is the formation of SS overlapping. Okay, so in SS overlapping, in this case there is a overlap of two half-filled s orbitals along the internuclear axis. Okay, so this is SS overlapping. Next is SP overlapping. This is the S orbital and this is the P orbital, which forms a SP overlapping. This type of overlap occurs between half-filled s orbitals of one atom and half-filled p orbitals of another atom. Okay, half-filled s orbital, half-filled p orbitals of one atom. Okay, they forming the sp overlapping. Next, there's a pp overlapping, p orbital. This type of overlaps takes place between half-filled p orbitals of the two approaching atoms. These are half-filled p orbitals. Okay, so this is the pp overlapping. And the second thing is, next is pi bond. Like sigma bond, there is a pi bond. In pi bond, in the formation of the pi bond, the atomic orbitals overlap in a such a way that their axes remain parallel to each other. Here, their axes remain parallel to each other. Um, and perpendicular to the internuclear axis. So this is about the pi bond. Here in this is the example for pp orbital. This is p orbital. This is also p orbital, which gives pp overlapping. In pp overlapping, the orbital formed due to the sidewise. This is a sidewise overlapping consists of two type charged clouds above and below the plane of the participating atoms. Okay. So this is about the sigma bond and pi bond. Here we can discuss about the strength. Okay, how the strength of the in overlapping, there is a sigma bond and pi bond. Here the strength of the sigma bond, basically the strength of the bond depends upon the extent of overlapping. In the case of sigma bond, the overlapping, in this case the overlapping sigma bond, the overlapping of orbitals takes place to a larger extent, hence it is a stronger as compared to the pi bond. Sigma bond is stronger comparing to the pi bond. Okay, so this is about the type of overlapping and the nature of covalent bonds. There's a sigma bond and pi bond, ss overlapping, sp overlapping, pp overlapping. Okay, and in that then there is a pi bond. This is the pi bond.